This is Daniel Coosbury, and in this video we're going to look at a few other ways to talk about the center of a data set. So this video should really go alongside the one I made that's just for the mean. There's a bunch of ways of finding means that are all good and helpful, and I just thought that these would have made it too long. So these two measures of center get their own special video. So let's go ahead and look at the median. So we use the mean an awful lot to talk about the middle of the data set, but there are some weaknesses that it has that might make us want to use something different, like the median. So the median is a special number that basically splits a data set in half. So the important thing with a median is you got to think of the data set first as a bunch of numbers ordered from least to greatest. So oftentimes when you collect the data, it's not in order. You've got to put it in order from least to greatest in order to talk about the median. But if you order your data set from least to greatest, your median is either going to be the number smack dab in the middle of the data set, or it's going to be a number that splits the data in half that's kind of between some of your data values. And I'll show you what that looks like in some small data sets. But this is a rule for finding the mean. So if your sample size is odd, so if there's an odd number of data points, the median is going to be the middle number once the numbers are in order. So you order them, pick out the one in the middle, that's the median. It's not hard to find. If the sample size is even, then the median is going to be the average of the two middle numbers. If you ever done anything with medians, you probably remember this as well. We'll average the two numbers in the middle, and whatever that average is, we'll call the median. So that's a frustrating thing to say. Whatever the average is going to be the median. You'll see this in context. Okay, so here are two data sets. They're actually really similar. I just added a number on the end. These are some of the grades from the mean PowerPoint. But we want to find the median now instead of the mean. So rather than saying, oh, look, there's 92, that's the median, we actually forgot the first step to find the median, which is first start by writing. You got to write the data points in order from least to greatest. So I'm going to reorder the data first. So I'm going to put 68, then 78, then 83, then 85, and then 92. So now I'm pretty confident I've written these in order. And oh, look, my pen messed up, and it seemed to highlight the median of this data set, which is 83. So once the data is in order, I can say that's the median with confidence and have no issue at all. So this is an example of an odd data set. In this case, n equals 5, which is odd. So once you order it, you just find the number in the middle and pick it. So now I added a number here. So I just added 100 grade because, you know, it's nice to get 100 on something. But now this makes this sample size even instead of odd, which means we're going to need to use that other technique to get the median. So let's start again by ordering this data. I don't have to think too hard because I already ordered it the first time. And then I added 100, which is at the very end because it's the biggest number anyway. So now that I have 6 values, I don't have a number that's smack dab in the middle. So what I'm told, in order to count the median, I should take the average of these two numbers. So I can do 83 plus 85 divided by 2, which is going to be the number exactly halfway from 83 to 85, which is the number 84. So the median in this case is 84. Now here's something interesting. 84 is not in the data set. But technically speaking, by the definition of the median, it is the median. So an interesting property of the median is the median does not have to be in the data set. It's worth saying again. The median does not have to be a number in the data set. Sometimes it is, like 83. Sometimes it's not, like 84. But either way, though, this number perfectly divides the data in half. So these three numbers are less than 84. These three numbers are bigger. Same here. This divides it in half. These are less than 83. These are more. That's all it really takes to find the median. The one reason you might want to use the median instead of the mean is the median is what we call resistant to extreme values. So here's an example of what I mean by an extreme value. So we have 5 families who have average annual incomes that are listed here. And then one family whose income is listed $25,000 wins $1 million lottery, so their new income becomes this. So let's think of this as 2 data sets. Let's think of the first data set as being these 5 numbers. The second data set's going to not be this 25,000 anymore. It's going to be this one, this one, this one, this one, and then the new 1 million number. So two different data sets, one with no lottery, one with the lottery. So before the lottery win, the mean of your household incomes was 38,000 and your median was 34,000. These are kind of close together. They're not telling you the exact same thing, but they're pretty close and they make sense. However, look what happens to the mean once the lottery win happens. So once the lottery win happens, you no longer have this 25,000. It now becomes a 1,025,000. The mean annual income of families in the sample shot up to 238,000. Now, do you think this number, does a really good job of describing what's going on in this sample? Not necessarily, because four of these families make a lot less than this, and one of these families makes a lot more than this. I don't think this number is terribly helpful. And I know that because I'm looking at the data and I'm looking at the mean and I'm making that kind of decision. But now notice what happened with the median. So when these numbers are in order, you got 1, 2, 3, 4, 5 in order, the median's 34. But when you take out the 25, so let me see, I don't really have a lot of room to write on here. When I take out the 25 and I write in my 1 million here, my order now becomes this one, then this one, then this one, then this one, then this one. My new median's this, which might do a better job of describing what's going on. So if I'm asking like what's describing this data set well as far as the middle of the data, I would say, okay, well this is better because most of the values fall around 44,000. This one doesn't, but the rest of them do. Like the rest of them are pretty close to 44,000, relatively speaking, even though this one's not. So the mean is not resistant to extreme values, whereas the median is resistant. So if you add an extremely small value or an extremely large value, the mean's going to shrink or explode, or can. Whereas the median doesn't do that. You add one value, the median doesn't change very much. You add one tiny value, the median doesn't change very much. So it's called resistance. So this is one reason why you may not want to use the mean for every single thing you do. You might want to use the median. At the end of the day, it's going to be one of those judgment call things. People disagree. No one's going to say use this all the time or this all the time. So it's helpful to know how to do both and work with both. This picture is really nice. So this shows you how the mean and the median relate when you have different shaped data sets. So for a symmetric data set, when it's perfectly symmetric, the mean and the middle number, the median, are the exact same thing. When your data set's skewed to the right, you find that your mean is here, but your median is closer to it's a little bit further to the left. It's a little closer to the tallest point. The median's not always going to be the tallest point, but it's going to be closer to the tallest point sometimes than the mean. The mean's going to be a little bit shorter. See that? Whereas here, the mean is the tallest point and the median is. When you have a data set that's skewed to the left, the mean is going to be a little bit at a shorter point than the median. Oh, that's not really straight. It should go like right there. But the mean's going to be a little bit shorter than the median. The median's going to tend towards where the taller part of the distribution is. It'll hardly ever be the exact tallest part, but it's going to be pretty close. Closer than the mean, especially when the data's skewed. It's a good, interesting thing when you're dealing with a few different data sets and you're trying to decide which one you want to use. It's a helpful thing to know about those two things. Okay, the other measure of center in this section is called the mode. And the mode simply refers to the most frequent value in a data set. So we've actually used this word before when we're talking about the shape of data. And we used the term unimodal to describe having one mode and bimodal to describe having two modes. So that was the data set that looks kind of like this. Unimodal just looks like this, something like that. So the mode's just the most frequent thing or the highest thing. So on a histogram or a bar graph, the mode is the tallest category or the tallest thing. So the mode's really easy to spot. Now, a little word of caution here. So we call the mode a measure of center. Maybe talking about where the middle of the data is or where most of the data is. But it's not necessarily going to be the center of the data set because in this example, there's a lot of data over here. And it's all about evenly scattered. There's just one category that's huge. The rest of them, even this one's about the same height as that. So like there's nothing really special going on with this data set. It's all low except for this one. So your mean's probably going to be somewhere over, maybe over here, whereas your median's even going to be further, maybe over here. So that's probably going to be your mean, and that's going to be your median, or something like that. But the point is, this is hardly in the center. And so maybe we don't want to call it a measure of center, but it is a helpful thing to highlight. And there's definitely something going on with this data set if all these are about the same height and this one's not. So the mode's a helpful thing to know and know how to find. There's actually there's 3 different things that can happen when you're looking for the mode. So it's possible to have one mode in a data set. It's possible to have more than one mode in a data set. That's my greater than or equal to 1. It's also possible to have no mode in a data set. So mode meaning the most frequent number. So in this first example, this is a data set. My mode is obvious. The most frequent number is 23 because it shows up twice. So my mode is 23. That's easy to see. So this is an example of a data set with one mode. In this data set, I have 2 23s and I have 2 27s. So here's 2, here's 2. So in this case, I would have 2 modes. My modes would be 23 and 27. So see, it's possible to have more than one mode because these both show up twice. Neither number shows up more than the other, but they do show up more than these. This is an example of more than one mode. And it's also possible to have no mode at all, like nothing shows up more than the rest. So there's no mode here. Let me show you real quick. It's also possible to have a no mode data set that looks something like this. So here's the numbers: 5, 5, 5, 6, 6, 6, 10, 10, 10. So this is my data set. And if I were to ask what the mode is, you'll say, well, hold on, these all show up 3 times each. But the mode is the number that shows up more than the rest. So none of these numbers show up more than the rest. They all show up the same. So we're still going to say there's no mode in this data set. Even though they show up several times, not one number shows up more than the rest. So there can't be a mode. See how this is different than this one where there's 2 here, 2 here. The reason these are modes is because they show up more than 26 and 22. So they call them modes here. And none of these numbers show up more than the rest, so there's no mode. So those are the 2 most common measures of center. You can call them measures of center that aren't the mean. So in summary, we really have kind of the mean, the median, and the mode to describe the center of a data set. And sometimes you just want to know what all of them are, and you can make some judgment calls later. But if you haven't seen the video on the mean, go watch that one next, because these really do go together. And this is how we're gonna use to describe pretty much every data set from this point out. We're gonna be interested in where the middle is.